Hello, hello. Welcome to the Good Garbage Podcast. My name is Ved Krishna. My primary reason for existence has been to find ways to leave our wonderful planet cleaner. We will be speaking with material innovators, creators, and propagators to learn from them how we can build for scale and towards a regenerative future. Their stories will help us answer the big question: what is good garbage? Troy Swope has been a hero when it comes to scaling in the domain of regenerative packaging. He and his co-founder, Yok Chung, are building their company Footprint as a leader in the food packaging space. They have adapted their backgrounds in the tech space. They both spent over a decade with Intel to challenge status quo and innovate. This is a practical, energetic conversation exploring ideas around packaging and scaling. Enjoy. Hello, hello. I'm just so happy to welcome Troy Swope today to our podcast. A little bit of a backstory first. I've been trying to get in touch with Troy for a long, long time, and he keeps ignoring me. So finally, we got him. And I'm so happy to meet you, Troy, because of that. And as we were discussing before, we have lots of good common friends, and they've been trying to get us in touch. And this is a great excuse to get in touch because I'm sure there'll be so much to talk about. I've been listening to the work that you're doing and the kind of difference that you're making, and I'm so inspired by what you've achieved, and so excited to exchange notes with you, to talk to you, to learn more about what Footprint is doing, to be able to get your thoughts to the listeners. So thank you so much. Thank you. I know you're a very busy man. Thank you for taking the time and getting onto the show.
Well, thank you for having me. And now that I know we have so much in common, I wish I'd have got a hold of you sooner. Yeah, thank you for having me. This is fun.
Wonderful. So as they say in our part of the world, it always happens at the right time. So this is the right time, and take it from there. So a lot of the conversations I've heard from you, numerous interviews, all start at Intel, but I don't want to start there. I want to start way before. If you can think about your childhood, and if there was instances that you can think of where packaging influenced you in any way, or tweaked your interest, if you can think back before Intel and talk to us about what really was inside you that got you in this warrior sort of mission.
Well, I don't know if I could look back in time as a kid and think that I thought about packaging much, but I certainly thought about the environment and the ocean. I grew up in Southern California, in Mission Viejo, California, and we're really close to the beach. I have two older brothers and myself where we lived at the beach all summer long, surfing and boogie boarding, and the ocean was a passion for sure. And in addition, I had grandparents that lived in Santa Barbara and that ran a church camp in Santa Barbara on about 300 acres, and my grandparents were really into the environment and into flowers and trees and conservation and fighting wildfires and how to manage a forest. So the environment and our planet was very important to me at a very young age. And I think the aha moment is before I became, for lack of a better term, a material scientist focused on sustainability. I was going to say an accidental environmentalist, but I had someone point out to me that said nothing in my life is really accidental. So he didn't believe me. And I actually now go, that's true. I can't say I'm an accidental environmentalist anymore. But I went to Hawaii. My dad lived in Hawaii. So I spent a lot of time in Hawaii. And I remember watching parts of the ocean change as I got older. And tying that back in as a scientist at Intel, an engineer at Intel, going, what are we doing to impact that? Why is it changing? And man's impact on that. So all of that, as I stumbled on the problem that is plastic in humans today, was always on my mind. And I was so concerned, the father of four, that we are going, and we're already doing this, Ved, right? We're having to tell our children what everything used to look like. Right? I mean, we're already doing it, right? The ocean used to look like this. I mean, I used to go to Bali in the 90s when I was at Intel, and in Malaysia, we'd shoot over on the weekends to Bali, and it was so awesome, beautiful. And I just went there recently, and there was so much pollution and plastic all around the beaches that I was like, this didn't look like this 15 years ago, 20 years ago. And it was heartbreaking.
Yeah, so clearly the seeds of your environmentalism were sowed in early. And I have a similar experience, and this is off the coast of southern India, and the Kovalam beach on the Kerala side. And I would dive there as a, maybe a 19, 20-year-old, pristine, beautiful oceans. And then about 4, 5 years back, my older daughter is a diver and we went there. Oh my gosh, Troy, it was heartbreaking. It was just,
Yeah.
the floor was littered with plastic. And we had to go way out to find at least the floor not being littered by plastic. You would still have microparticles, but that's the
Yeah.
situation we've put ourselves in. And of course, you and I both are on this journey of finding ways to at least change materials. So I want to know more about the greatest challenges that you've found in building footprint and the journey that you've taken since 2014.
Yeah, very specific is just when you're trying to create a plant-based technology that performs like plastic, so shelf life, right? We see there's definitely a lot of low-hanging fruit where we could get, plastic-free technologies in takeout containers but where it's really difficult is getting plastic-free technologies in items that are extended shelf life. Like, I got an example here, like Annie's mac and cheese, right? So love this product, by the way. And it needs a year shelf life, and you can't, dehydrate the pasta too soon. And you got to be able to put, liquids and then put it in the microwave and no transference of any chemicals and those things. That gets difficult. Or frozen food for, ConAgra's Healthy Choice, where you need to stop a water molecule for a year, right? And slow down oxygen, right? So those things are real technical specific challenges. I think one of the things that I'm really, really excited about, and you probably feeling this as well, is that when we started the journey, roughly 8 years ago, we had to somewhat educate our customers on the dangers of plastic and the pollution. And we were really focused on plastics in your body, probably too soon. Now everybody knows it, right? Or is learning it. What's very exciting today is that the consumers and our customers know that plastic is done. They just got that. They need the material to eliminate it. They want it out. They want to be done with it. And especially away from food. I think plastic's got great useful life in our automobiles and in our computers and headsets and our phones maybe, but it's got to get out of food.
Absolutely. I was, in fact, being asked this morning, I was in another interview, and they asked me what one recommendation is for policy change. I said, actually, what we should do is have a singular trash can, and everything in that trash can must compost. And everything else that you remove from your house, like computers and stuff, you have to pay for. You have to pay for repurposing. So every packaging and all the garden waste and all the food waste, everything goes to composting and everything becomes life for something else. So very similar to what you're talking about. But I'm super intrigued about the barrier technology, and I don't know how much you can share, but it'll be interesting to know how you went ahead and solved this, because I know, and you'll enjoy this, because our tagline for one of our brands for molded products is the brand is called Chuck, and it says under it, "Eat safe." Because our branding guys said at that time, you're exactly right, about 4, 5 years back, they said like people don't care enough about the environment, but they care about their own health. So the tagline of "Eat safe" might go better. So it's very similar experiences to you.
Yeah, I like that. Without getting into or too much in our IP, I think one of the huge benefits, some of our core team is from the semiconductor space in Intel, and we were in Intel R&D. So Intel R&D taught us how to fail, how to build a hypothesis, design an experiment, and have an isolated variable and analyze that variable. And do it quickly, right? And because we're not from the space we're disrupting, it's been a huge advantage because we didn't have any preconceived ideas of what was possible. So we just used really good engineering discipline and everything from the process technology and the symbiotic relationship with refining fibers to coating fibers to intrinsic chemistries. We discovered that you can build technologies through fiber that have barrier properties, long-term barrier properties to replace plastic. Now we're still advancing those. The next frontier for us is greater control of oxygen. Oxygen barriers that we need for like K-cups and Nescafe cups and pods, and deli meats actually have real sensitivity to oxygen, right? So we need to control oxygen, again, plastic free. And that's probably one of the next frontiers. We do have technologies for dairy and proteins, water and oil. We do real well today, and we could slow down oxygen, but we really need to stop it in a lot of cases.
Yeah, yeah. If you want shelf life, that's a must.
Yeah.
Do you mostly do this through coatings or through internal chemistry?
They're symbiotic. You can do it all with a coating, but if you do it all with a coating, you're going to now start impacting your cost. You start impacting things like recyclability, compostability, those kind of things. Even though the coating is plastic free, with that coating, you put too much on, you start really impacting recyclability and compostability. And so you really need to control your internal chemistries in your airflow coming out of forming to really understand how much coating you apply. You need to apply very, very little.
Yeah, and it's also the additional step. What we find is that you want to churn out and produce as much as possible to take the costs low and to keep the cycle times fast. And as soon as you have another step in the process, you really create a high impact on the cost because you're sort of moving to another process. So that's the other challenge. So I totally agree with you on the internal
Yeah,
side.
and you understand this well, is that the plastic technology in machining thermoforming is extremely fast and efficient, right? So you're competing with that on price. And when you're doing a plant-based fiber or molded fiber today, which one is the process technology, let's be honest, is really still very immature, to me is a tremendous opportunity. It just creates so much opportunity. If you're a real good engineer and scientist team, you could use your advanced engineering and capabilities to develop process technologies that improve cycle times, improve product qualities, reduce costs, reduce energy. Because it's so immature, there's just this wide open space for innovation.
And a lot of people are doing stuff, so I'm sure we'll have lots of other opportunity to exchange those notes because I see so many interesting things happen in the space. And talking about plastic, they don't have to drain out 99.8% of water,
Yeah.
so of course
Yeah.
it's a lot faster. I just wanted to go back to your thought of not coming from the space of fiber. There's the story of Kimberly Clark taking over a mill when they still ran paper mills, Scott Paper Company, and they were trying to set up a new plant. And on purpose, they did not hire any paper technologists. And guess what? That was the fastest, most profitable mill that they had because they didn't know what can't be done. So,
Yeah.
so similar to
Yeah.
your experience, I think that's so good.
Yeah, that's a great analogy.
Yeah.
It's really been a huge competitive advantage for us is that we didn't have any preconceived ideas of what was possible. So our ideas was all things were possible. We just had to have the right engineering discipline.
Absolutely. And it's the common sense. One of the things one of my early mentors taught me and it stayed with me is that think of yourself as the fiber. So when you think of yourself as the fiber, you'll know what you feel like when you go through a slot, when you are refined in a certain way, and when you're drained in a certain way. So if you start thinking like the fiber, you get the basics right. So that's something that stayed with me. It's the simple things, right, that make a difference. So moving along, what about raw materials? So what I'm truly inspired by, is your vision to scale and to really, make a difference. Because we can talk all about creating these nice boutique technologies, but the pile is so large that if you're really going to make a difference, it has to be scalable. So how do you see that getting solutions on the raw material space, and is that a challenge that you foresee, and how are you planning to build that supply chain?
Well, we are scaling. We delivered hundreds of millions of units last year. I think we're billions of units this year. We have a factory in Mexico. It's 1.7 million square feet and 4,000 employees, right? So we're building 1.5 million square feet in Poland right now, and looking at Thailand. We have a team in China. So we are scaling quite a bit. So the best way to scale relative to the materials availability is you have to have a lot of flexibility, right? So if you're in a region where sugarcane production is high, obviously bagasse pulp is a really good option. China, you see a lot of bamboo, those kind of things. North America, it's hardwood and softwood. Now, with that said, the best solution for the planet is if I can use a recycled box. That's the best solution for the planet. It's a huge CO2 emission reduction when you compare to plastic. The energy that was used to make the box, you don't have to claim. It's already there for a fiber source. So we love that as a percentage of our materials. We can find boxes everywhere. We love it. It's very, very, very hard to use because it's unpredictable what it is. And you got cleanliness issues. And you got to get out the starches and glues and those kind of things. But when you can use that fiber, it has a huge impact on the planet, CO2 emissions, your cost structure is better. There's a lot of real positives. So we like that material. And then we feed in others, bagasse and hardwoods, softwoods, wheat straws. We have customers that want us to use pineapples and acai and some other things as well. And if there's value in it and we can get a good quality fiber, we'll do that. But today it's things that you really know: pine, hardwood, softwoods, recycle boxes, bagasse, bamboo.
It's wonderful that you're able to use OCC or old corrugated cartons, but like one of the challenges I find in the waste paper streams is food security. Are you able to make sure that it's FDA compliant if you're using waste papers?
Yeah, there's a couple things with FDA compliance on waste papers. One is your coating technology can help you there, and then if you're not applying a coating to the material, the heat and temperature and your cleanliness of your process. So how you sort, clean, refine the fibers are critical. But if you do those and you have a high heat process step that kills any potential bacteria, then you can meet all FDA guidelines, if you will, and BFR for that matter. A little bit harder. So this is one of the, and you see this with bagasse, right? So bagasse is actually a really difficult fiber to recycle, right? So once we use bagasse, none of the world wants to use it again. And you see this with OCC, recycled box. You don't know how many times a box has been recycled. So this is where the potential of the environmental metrics recyclable is really bad. It could be really bad for the planet. An example of this is I have a customer in Europe. They so hung up on the word recyclable that I can't use recycled content fibers. I have to use 100% virgin material, which drives a 40% increase in my CO2 emissions for it to be as recyclable. And the reality is when it's got coffee or anything in it, it's not going to be recyclable anyway, right? So it's going to go to a landfill, where it'll degrade and actually release methane that can be captured and reused to drive trucks like we do in the US, right? So the word recyclable is a bad metric that actually I think hurts the progress of the planet. We really need to be focusing on CO2 emissions and greenhouse gas emissions. We don't want to glue a leaf back on a tree, right? It harms the tree, right? So if the tree loses its leaf, it's part of nature, and we use that leaf to make something useful, like a single-use, food service item. Let it go back. It's done, right? And it doesn't harm the earth to degrade.
I couldn't agree more with you because there is actually, and I'm sure you understand this even better than me, is there is no such thing as recycling, number one. It's all downcycling, and there is a end of use that will not happen eventually. When you say recycling, typically the consumer feels that it is actually just being created into the same thing, and it's not. When I think about the place I come from, which is India, so 80% of the paper is recycled in India. But the great dissonance there is that most of the waste paper is collected in America, packaged, sorted, sent all the way to an Indian port across the world. Then you take that and ship it up inland to some facility. You recover maybe 50% of that and create a downcycled product and ship it right back. So, that is the kind of damage when we look at recycling, and we don't realize it.
And the CO2 emissions from the transportation and all that is huge, right? So, look at aluminum. We are all very excited about aluminum replacing plastic, but it's 200% more of CO2 emissions and greenhouse gas emissions than the plastic it's replacing. So we got to be careful. Like end of the day, the bottom line metric is climate change, CO2 emissions and greenhouse gas emissions. And certainly you can't poison people, right? We got to assume that you're not poisoning people like plastic does. But that should be the metric. So if you can use a renewable material or an agriculture waste like bagasse, and after you use it, it degrades, that's a great solution. We don't necessarily want to force recyclability on a bagasse item.
Yeah, no, absolutely. Do you see any difference in products? Because when we look at different fibers, they typically have different morphology, and that creates a different feel to the product in terms of the stiffness, in terms of the bulk and things like that. And when you look at different fibers that you use, because you have experience of so many, does it behave differently when you look at the product itself in terms of stiffness and stuff, or you're able to balance that?
Yeah, absolutely, right. So if you use 100% of one fiber, we generally find that's not the greatest strength. The reality is that a blend, actually, there's a lot of advantages from using a recycled box. The starches in there are food safe starches in most cases in the United States, add a lot of structure. But the surface finish isn't that great. So then you combine that with a bagasse or some other items and you get a real high quality part. But each fiber has a different mechanical property that has benefits, right? So as you engineer them, you'll find recipes of fibers that give you the ultimate part, which includes, helping you with your oil barrier and water barriers. The fibers actually can play a really important role in that. And if you control that right, that material mix, and get the right webbing, if you will, under a microscope, you can reduce your chemistries and reduce your overall cost.
Not just the fiber, what we have found, and I'm sure you know this again, is compression. The compression and heat in terms of the structure. And if you're able to apply higher hydraulic force and you're able to apply higher heat, which means lower cycle times, you typically get more hydrophobicity.
We're doing a lot with what we call dry molding with a partner and on our own as well. We think there's real applications for it. It's going to be real difficult for a cup, like a cup of noodles, and where you need a deep draw and real strong barrier properties. But it's going to be for food service items, protein trays, those kind of things. I think there's a future for it. It's going to be part of the solution. As you and I know, we're going to need a lot of paths to success to eliminate plastic, right? And there's going to be cell-wise, there's going to be dry molding, there's going to be traditional wet molding and advancements there. There's coating technologies. All those are going to have to come together. I mean, we have a real challenge, right? Footprint is experiencing explosive growth, and we're going to deliver billions of units, and we're all over the planet. We have the top CPG and the top retailers and top QSR companies all in the world are our customers today, and we are going to be a fraction of a percentage of the total volume of plastic, right?
Oh, yeah,
so
absolutely.
There's going to be partners here for us to really make and help the planet.
No, absolutely. And we are absolutely aligned when it comes to the idea. So I wanted to go back to chemistry and how are you, sorting this whole hype around PFAS in US? And I know it's not an issue in other parts of the world, but US has somehow taken a lot of interest in that domain. How do you plan to, especially on the oil proofing side, if you manage to find something which is actually scalable commercially, and how are you trying to solve that?
Yeah, we have developed an oil barrier PFAS-free. In fact, where we have a 12-month shelf life with ConAgra's technology, frozen food, which oil barrier, in a secondary coating. Right, so we created a secondary coating operation that creates it. But I mean, PFAS is in your tap water, or fluorinated chemistries are in your tap water. So in our operations in Asia, that even when we go PFAS-free, there's so much of it in our water that we still find trace elements of it in materials. But in the U.S., we've been able to get all that out. But it's been an advantage for us, frankly, that we were working with ConAgra 7 years ago, and they said they had a vision for fluorinated chemistries were going to be a problem. So we started immediately going, all right, so we could use it maybe for the first year, but we got to have a new solution a year later, right? We were already working to get out of PFAS. So we got out of it 7 years ago, and so it's been a huge competitive advantage for us because when everybody started going, I need PFAS-free, we've been out of it for a long time.
But what about internal chemistry? Have you been able to sort that as well, or it's still through a coating technology?
We have some oil barrier technologies we actually are doing some work with margarine that are all going to be internal chemistry. So if you think about it, we're pouring oil, solidifying it, and it's got a 6-month shelf life. And so we're doing that 100% PFAS-free and without secondary coating. Yeah, we were able to solve that. That's been a significant win for us. But we still need for secondary coatings for like meat trays, protein trays. There's so much water. You need the structure. We need secondary coating operations for anything that needs it really just control oxygen.
Yeah, also shelf life, I guess. That's a lot of the products that you're doing are in that space. And are you able to get the right coating materials to be home composted, or it'll all be like industrially compostable? Like
we target everything to be recyclable and compostable. We're not there with all technologies. Like I said, when you use a lot of recycled content, recyclability gets impacted. Right, so we really just talk to the customer and go, what do you want? And we show them, like, here's your CO2 emissions impact if you want a virgin fiber. If you want a virgin fiber, your chances of recyclability are much higher. But the reality is, you know this, when we put food in it, the expectation from the recycler is that we clean this out and then we recycle it. That's not happening. So we really don't control recyclability of fiber. Now, we design everything to be, we want it to be composted. I don't believe true composting is the future. I think like some food dehydration, where you could, take food and, footprints materials or fiber materials, you grind them down. Lomi is, like they're doing a lot of work like this. There's some other really exciting companies coming online. We're going to be an investor and a promoter of these technologies. I think they're going to be in everybody's home. And our technology breaks down really nice there. And then you start now or start talking about the future of waste is actually could be upcycled. So you take all this food waste and your fiber waste, you grind it down, dehydrate it, and you could actually bring it back into as a nitrate-rich fertilizer for leafy greens, and depending on the fiber content, being a food source for hogs and some other items as well. So that could be an actually upcycling of the waste. That's, I think, the future of waste. I don't think certainly recyclability of a food contaminated plant-based solution is, we're going to see a lot of recycling of it.
I totally agree with you. In fact, we worked with a similar quick composting solution, degenerating it, and then they would compost it over whatever the next month or something. But you're right, it can be used for directly putting nitrogen into the soil. And this goes back to the idea that have a singular dustbin or trash can and put everything, the packaging and the food waste into it. Just try to break it down into really small pieces, and then you can dispose it.
We were a sponsor of the Phoenix Suns. The arena is the Footprint Center. We have a vision with the Suns to do something very similar, that there's one bin. And that one bin, you put all your plant-based materials and your food waste and everything in that one bin. And you might have a little bit of aluminum and glass in the facility. We'll have to figure out what we do there. But the vision is to get it down to one bin. And you dehydrate all of that. You'll start putting those capabilities in the center by 2023.
That's amazing.
Yeah, we're excited. We're excited about it. We've done it on a micro level, like home level, but we haven't done it in the massive amount of waste you would at an event with 18,000 people. But it just means bigger digester.
And I was fascinated with this idea of investing in a stadium and this. I want to know more about your thought behind that idea of investing in the Phoenix Stadium and calling it the Footprint Center.
Generally, it's banks and airlines that are the title sponsors for these arenas. Other than the brand value, which is significant, that's all they get. And the Phoenix Suns are just an awesome organization relative to their focus on sustainability and their openness to innovation. So we started talking to them about just making the arena a more sustainable place. And they were open to innovation and bringing in new materials, and even their whole water bottle system, changing it to flow water or blue water and bringing those guys in. And they're just totally open to it. Totally open to change the whole waste profile of the whole arena. And knowing that we were going to experiment and maybe fail and they're just totally open to it. So as we were in those discussions, and we're really, frankly, at this point now, we're a supplier to the arena, right? The opportunity came up for us to discuss title sponsorship. And we already saw a source of revenue creation there and a source of testing innovations. So it was really an easy leap for us to go, this is the most unique deal in sports, is that we were already making money from the arena and being a supplier, that we could be a title sponsor as well, and then really get a lot of freedom to innovate. So we're going to test things like our first paper cup got tested there, paper utensils, our paper water bottle are all going to get tested there, and you get 18,000 people to give you feedback, and you get a feedback pretty quick, right? So it's been an unbelievable partnership. We're taking the best known learnings that we get from there and using it to work with other organizations that want to change as well. So and we have a number. We're working with just a number of NFL teams, a number of NBA teams. NBA's got a best practice policy. So we're excited about what we're learning and what we're going to learn, and then be able to transfer that to others. In addition to that, you got the branding, right? So you got people asking, who the heck is Footprint?
And that's amazing foresight, actually. When you think of it, you have this captive audience you can test on and see what works, what doesn't work. Otherwise we are always struggling to go out and do a few tests and see. So two of the things that you guys have again innovated are super interesting, and I would love to know more about those. One is that when we are doing molding, we always think about draft angles, and it's always a challenge when it's 99.8% water and 0.2% fiber to get the angles really narrow and to be able to get deeper products. But clearly, you've solved the cup challenge and found a way to keep pretty steep draft angles and deep products. And the second is the lidding solutions. Because sometimes the lidding, if you're especially doing a molded product, it's more costly than the bowl, and nobody wants to
Yeah,
pay for it. And I see
yeah.
many of your products on the shelves now, which have a paper-based lidding solution. So you've clearly got the glue right and the heat sealing right and managed to get that right. So it'd be interesting for me and the audience to know more about how you went about that, and as much as you can share in terms of the technology.
Yeah, I don't know how much I can share on the lidding films. I'll get beat up there by my legal team. But so the relative to the lidding films and the cup and everything, it kind of follows the same methodology, right? My partner and our chief technology officer, Yoke Chung, leads those efforts, and he's got a very large team now that just focus on good engineering discipline and principles, and they design and they fail. And we're really proud of our cup. I think you're going to see it's out there today, but in low volumes. But later this year, it'll roll out really, really high volume. We're scaling it. And then you'll see it in mass volumes in 2023 and billions of units in 2024. So we're excited about that. But yes, it's quite the innovation in draft angles. The key is those draft angles and then still maintaining a very high cycle time, right? Because if you look at some of the Apple products today that are really fantastic in fiber that China's doing, have really, really small draft angles, but they're very shallow, which is fairly easy. But when you get a part that's 20 millimeters and you got a 4-degree draft angle, it gets really hard. It took a lot of tooling innovation, a lot of failures. One of the real challenges in that draft angle is being able to maintain your chemistries and maintaining the fiber quality and consistency, so you don't have any thin walls or spots, which is critical when you put in hot coffees and creams. And in our case, for the Phoenix Suns, we put alcohol in these are in well. If you put alcohol into a traditional rolled paper cup, you're popping that seam in 30 minutes, right? It's bursting. Ours alcohol will evaporate before it leaks through.
One of the big things and one of the inspirations for me has been this idea that you want to see the entire supermarket not have any plastics in 5 years, which is a huge ask. And we probably said it last year, so it's 4 years now. So taking a cue from that, one of the things that we have been working very hard on is the flexible packaging side. So how do you see that whole domain of flexible packaging, and how are you taking a crack at it?
We haven't gone into it in great detail, to be honest with you, Ved, today. We know it's an opportunity. Now, we have seen a number of customers, large CPGs, take their products out of flexible and put them in rigid. It's a better user experience than dipping your hand in through a bag and trying to pull out the items, versus where you can have a cup or a small tray, which is a little easier for the user to get to the product. You have to worry about shipping densities and those kind of things, but the user experience is better. So that's one way that we've seen it, but it's not footprints focused today. We have a huge competitive advantage and lead, if you will, in extended shelf life for the supermarket items for rigid plastic. That's where we're really playing today. We are working on other items, water bottles and shampoo bottles. Now it's all about how do you design the shape, the geometry, and seal, right? Are you going to use a traditional bottle shape? Are we going to do something different, that makes it easier to form and actually easier for the chemistry and coating to work? But we do have all the technologies that will work. Now we have to marry them with the right geometry.
I'm excited to see, and I like your thinking process that it doesn't have to be same old, same old. Our design engineer was fabulous, and he talked about this. We were trying to construct a paper bag, and he said, why does it all have to be the plastic bag? And he started thinking about pomegranates. And he created a bag which will scrunch down into a really small ball. And when you put something, it expands. He used his origami techniques to have the right folds, but super interesting. So if you can challenge the supply chain, then again, you don't know what you're going to come up with. And
look at some of these like protein bottles. When you get to the end, your hand can't fit in it. There's always some in the corner. Yep. An actual rectangle is a better shape. It may load better on a truck and shipping and stuff. Some shapes could improve the user experience and change. They're just so used to doing it one way, but there is going to have to be some compromise to get out of plastic from the customer. The consumers want that, though. They're open to it. Wonderman Thompson has great data that's 85% of people feel guilty when they use something in plastic. That's an incredibly high number.
Yeah. Yep. That's amazing. And there's a company in India that actually challenged it. They still use plastic, but the shape, it's paperboard and it's become super popular. And it's like a flexible film bottle. And they just have a little plastic cap on top, but it totally squeezes out all the drinks. And they have a range of drinks that they do in that shape. And they've just created their own personality because of that. And of course, the material is still poly-based, but just the idea that you can challenge status quo.
And I think that the world's ready for it, right? I mean, they want to see something different, especially when it's an attempt to be better for the planet. The consumers are smart now. They'll understand, okay, this is better for the planet. I can compromise, what I'm used to versus something different that I might end up liking more. I think in a lot of ways, there's opportunities to improve the user experience.
Absolutely. And I do think that you already have a good handle on the flexible packaging side. And I'm sure you know this by the lidding. You're already doing some flexible packaging in a way.
Yeah.
And it'll be great for you guys, your R&D team. I'm sure it's thinking about it already. But to use that substrate and to create more flexible substances as well. Because yes, I agree that the rigid form is a good experience, but then, the costing and the transport and, everything else. So that I'm sure that same idea of barriers will work in a flexible methodology as well.
Yeah, we're doing some, things like folded carton. You can see the folded carton here and stuff that we're doing like for pizza boats and stuff. We're actually using in something completely outside of engineered fiber is that we're coating paperboard. With our coating technology, and it saves about 50% on the current coating costs. So, and eliminating any potential plastic coating, those kind of things. So there's all kinds of solutions that we can give to our customers that are plastic free that we're going to look in all different areas to support them.
It's amazing what you've done with the SPAC. Like you've just taken something and created enough capital to sort of really be able to scale. So I'd love to know more about details. The way I understand it is that somebody comes in and promises you a whole bunch of money and then prepares you to go public, and that's when they get the returns. Do you get cash from the sponsor initially, and how does it, like, give me more details on how it works?
Yeah, so what happens is there's a financial institution or there are a created group of investors. They go out and create a special purpose acquisition company. So that's the SPAC. They put up a dollar value that they're going to 200 million, 300 million, 800 million, whatever it may be, and say, hey, the SPAC's worth this. And then they go find companies that want to go public that will take over that SPAC called the D-SPAC. So once you go through the process, you're D-SPACing, right? So they go find a company and say, hey, I've got $350 million for what X percentage of your company, which is negotiable. And then if you want to raise additional money, it's called the PIPE, which generally you do. You want to validate, it kind of validates the deal. So you say, all right, I got a $350 million and I'll raise another $200 million. So my total proceeds, say, let's say $550. The PIPE raise is important. So your SPAC sponsor, you kind of set the value of the business. And then you go raise a PIPE that kind of validates the value of the business. And then you go file your S4 and then go through the SEC. And once you get through all the SEC questions, and then you have the ability to go public. And then the name of the business goes from the special purpose acquisition company to Footprint or whoever it may be. Those proceeds you don't receive until the transaction's closed.
In our case, we have gone through traditional funding for years and years. We've been in existence for 40 years. So it's been typically some equity from our side, and there is some loans that'll come through banks. So I would love to learn more about the whole idea of creating this SPAC and the flow of funds and how you plan to use those to be able to achieve the dreams that you guys are trying to achieve.
Yeah, so we definitely need to continue to raise money. We're seeing explosive growth, and I think even in a recessionary environment, people go back to the supermarket, they go to the QSR, versus going into big sit-down dinners. We're going to continue to see that explosive growth, and we needed a lot of capital to meet our customer demand and to grow. We're obviously building factories in Mexico and Poland and Thailand. So we're going, all right, so how are we going to fund this? And we looked at different vehicles, traditional IPO, the SPAC, which is just another way of going to IPO. Now, it's a little bit more of a compressed timeline, the SPAC is. I liked it, and my team liked it. There was a lot of certainty in the deal, right? So you know how much the company you're selling. You know how much proceeds you're going to get. We happen to have the best sponsor in the world. So Gores this is all they do. They're 100% dedicated to this vehicle and taking good companies. They do more due diligence on companies than anybody. So we knew that if we could get a sponsor like Gores, that it was a great vehicle for us. And they not only do amazing due diligence and help you with deal certainty and getting the proceeds you need to grow your business, they help get you ready to be a public company. And they let you know where you're weak and not weak and where you need to fix. Fortunately, we have an amazing board, real professionals, the former CEO of McDonald's, the former CEO and founder of Broadridge Financial, former CEO of Intel, the former CEO of ADP Payment Systems. We have an amazing board. And they help us and said, okay, we're ready. You can get ready. We'll help you get ready. So the combination of a great sponsor and the fact that we needed so much capital to grow our business, and we're building factories all around the world, it's been a good vehicle for us. We'll see.
You are private limited for now, I guess, and now you're going to go public. So what is the kind of dilution that you've had to go through in this process?
We're on a Series C raise, so every time you've been diluted, right? So it's just, you got to look at the value of the business at each time you raise, and the value of the business as you go public, and then the amount of proceeds and where you're going to be in the future. We believe Footprint will be recognized as the most environmentally impactful company on the planet pretty soon. If not, we're already pretty close, right? So the immediate dilution is not really concerning to us as much as it is to have the proceeds. And I know it sounds, when you say you're the most environmentally impactful, we've already been recognized by CNBC and Newsweek and others, top 50, top 25. But the reality, and this, Ed, is that the impact plastic is having on human health is way more significant. Plastic production is one of the third largest contributors to CO2 emissions and climate change, not to mention the pollution on the planet. So by eliminating plastic, I can't see another area that has so much impact, not only on the planet, but on human health. So we feel, with our scale, we don't know anyone in the world that has near the capacity that we have and are investing to have in the next couple of years. So we feel it's going to be very quickly that we'll be recognized that this is the most environmentally impactful company on the planet. Basically, we believe it's a new model of you could be pro-planet, pro-profit. We often say that, if you want to figure out who Footprint is we're like a 3M dedicated on creating a healthier planet. 3M is very good at directed innovation. We come from Intel, so we always thought in scale of billions and globally. We always said this was going to we needed to produce billions and billions of units, and we needed to do it globally, and that there's a huge demand for it, and that we thought we'd have a real strong technical advantage to the current environment, and that's played out. We have a huge competitive lead, and we're real excited about where we are in the team and working with guys like you, and guys like you and I that are building these materials. We are helping, but the reality is the champions here are these brands, General Mills and ConAgra and Tyson and all these guys going out and taking significant risk and testing materials and failing and learning and to do something better for the planet. I am so proud of our customers. McDonald's is another one that's just a phenomenal pusher of sustainability. Walmart, it doesn't get the credit they get. All these companies are really trying to do the right thing. You and I need to provide them the materials that allow them to do the right thing, and so that their sustainability efforts are powered by our innovation.
I couldn't agree more. And I've had the same experience. Of course, most of our sales is still India, but people coming up and saying that, I'm exporting so much frozen food.
Frozen food is our specialty, which actually, by the way, I would have never started with frozen food other than ConAgra is just bold, super innovative. And they came to us many years ago, said, we got to get out of plastic. And we were dumb enough to say, okay, let's start with frozen food. And it was super challenging, but was really great because we learned so much that what we learned was the building blocks for every part of the supermarket. Frozen food, the challenge is you're taking hot food, oils, liquids, flash freezing it, sealing it, And then in a year, they want to be able to take it out, put it in an oven and or a microwave, and no oil leakage. So that was a task that we thought, it seemed impossible. But once we solved that, we really had the building blocks to do just about anything.
Who are the companies or people who are really inspiring you as you make this change? And you mentioned some of your customers, but them and others, it'll be lovely to hear for the audience, who are the people who you think are making great change.
I'm really inspired by our customers. They inspire me every day. They push us every day. And I always feel I want to do more for them. Upfield is one that, the Unilever spinoff, I can't believe it's not butter is the product here in the U.S. And their vision, their commitment to change. ConAgra, always, that they have an unbelievable leadership team. And I think probably one of the best CEOs in America. They're very inspiring. Working at Intel for 15 years, I was that customer. And knowing how difficult it is to change a massive company and to go through innovation and take those risks, I'm quite inspired by the people that do that. And all these companies, they want to do the right thing. They're really just looking for the right supply partner that can provide them the technologies that will match their innovation and match their development and understand how to fail and not give up. And that's where Footprint's been successful. On the material side, everybody inspires me. Just in our conversation here, you're inspiring me, and I'm excited for what you're doing and would love to work with you. And as you know, it's going to take a lot of us. Plastic is a massive, massive industry, so it's going to take a lot of us coming together to really make a dent for the planet. So I always call them competitive partners. We need more competitive partners to go and really have a massive impact on the planet.
Absolutely amazing. So my last question, which I love to hear from people, is what does the idea of good garbage mean to you, and how would you want to see that translating for our planet?
Well, I think the idea of good garbage is we stop thinking about recyclable that doesn't get recycled, right? But I think your idea of a single bin, right? Food waste and anything that is carrying our food should be able to be ground down with our food and then go back out to the planet and not harm the planet. If it's carrying our food and actually is potentially in our food, then it shouldn't be harmful. I think today, what's carrying our food makes us sick, makes the planet sick. It's just absolutely disaster. There's going to be good, there's going to be better and best. We just got to start making change quickly.
Yeah, absolutely. Thank you, Troy. This was such an inspiring conversation for me, and I look forward to many more conversations and meetings and possibilities that we can build together. Thank you so much for being on the show.
Thanks, bud.